Seconds. It's preparing. You should see any minute now something. Do you see something coming in? It's actually
seems to be live. Yes. Yep. Now it's starting.
Yep.
Perfect. We are live.
Excellent. Should I start?
No. Nobody's in. We have to let people in. Okay, I let people in.
Makes sense. It's all yours, Nigel.
Just wait. Hello, everyone. We are waiting a few more minutes for people to get into the talk. Maybe one more minute.
Yep.
I think we can start. Or what do you think, José?
Yep. Let's. Well, it's 6 o'clock. I think we can wait 1 or 2 minutes for giving a bit of margin. So we are at the moment 12 in YouTube, and here we are 13 with 93 registers. So I guess we give a 2-minute margin and then we begin with the user group introduction.
For people who just joined, we are waiting just 1 or 2 more minutes, and then we will start.
Yep.
Okay, Martin, I think there are still people coming in. Jose, there's still people coming in, but I would start now.
Okay.
And I let them in while.
Yep, makes sense. Let's begin then.
Okay, so welcome to the .NET User Group Zurich. Special thanks to our sponsors that make these talks to make these talks possible. And we're doing this in collaboration with the .NET User Group Central Schweiz and the .NET User Group in Bern, organised by Daniel Marbach, Urs Ensler and René Leopold. This is a user group from developers for developers to share knowledge, create excitement in technology and network. So we often bring some pizza, but this time around we have no, we bring some beer. In my case, I bought some homemade schnapps. So who are we? We are these. I'm the handsome one on the far right, and there's Jose, Fabian, Mark, Michael, and I can't pronounce his name. Sorry. Okay. Anyway, so we try to do events regularly. We try to do quality talks and speeches and content. We like to network and having a good time together. We're trying to publish and stream these events online so that you can look at them later. Okay. So what can you do? You can follow us on Twitter, you can join our meetup group, you can tell your peers and help us grow, you can propose new content, and you can take part in lightning talks. So if you want to start to build up your speaking skills, like I desperately need to, then you can also make a 10-minute talk on something that you know and you can share with the community. And today, yes, you can join into the Zoom channel or through YouTube. If you've got questions, you can post them on the site, Silo. Please subscribe to our YouTube channel. And I'm not sure what Zoom bombing is, but please don't. Okay. Okay, and of course, please, if you want to join us and make a talk of yourself on your own, please let us know, because we're more than willing to have you on our channel. Okay, and with that, I'll pass it over to Jose and Michael.
Yeah, just let me
Thank you, Nigel.
the sharing. Thanks, Nigel, for the
Excellent.
I stop sharing. And then let me share. So before we start, I want to really extend the invitation that Nigel already did. If you want to do a talk, you can sign up for the Swiss Lightning talks that we do at the end of the month. And this doesn't mean if you know somebody who wants to do a talk, also maybe give them a nudge so that they can try out their first public speaking experience with us. I think we would be more than happy to get more speakers from the community, so that we are not just presenting like speakers that are from conferences or that we do the talking. We want really people from the community. So file up with us, and we also help you along with the talk.
Yep, there to jump into the stage. We don't bite.
Yes. Okay. I think I hope everybody is all right, and we'll have fun with our talk today. I'm Michael Staib. I'm a Microsoft MVP, and I'm the author of the HotChocolate GraphQL library.
José Luis Latorre. I'm not an MVP, but I was an MVP for 9 years, and I'm the author of a .NET book on 4.5. And I work at Zuhlke Engineering as lead software architect.
Today, we want to explore with you how we can build real-time applications with GraphQL and Blazor. And with Blazor, Microsoft really gives us, for the first time in years, a proper solution to build real-time applications that run natively in the browser.
Yeah, they basically are putting us a UI developer in the front seat, in the driver's seat, and enable us to code like we have not been able to code before.
And we are pushing Blazor to the limit today, or bringing it to the next level by getting rid of all the friction that you have with data fetching technologies like REST, by putting GraphQL into Blazor, and with that, empowering the front-end developer.
Yep, correct. And we will do so exploring all the different attributes that make GraphQL what it is, and exploring all the benefits for implementing a real-time application and how it can shorten the development lifecycle.
So I know there are a lot of .NET developers that still don't know GraphQL, or a lot of developers have a misconception about what GraphQL is. So one of the biggest misconceptions out there is that GraphQL is some kind of a graph database query language. Actually, GraphQL has nothing to do with graph databases or with databases in general. GraphQL is a query language for your API and the runtime to execute those queries. Originally, GraphQL was developed by Facebook, and they developed it in order to basically solve their data fetching needs for their native mobile applications. Today, Facebook is using internally GraphQL everywhere, and other big internet companies like Twitter or Netflix are fully bought into the GraphQL space. In order to get you all hooked up to GraphQL, or give you an idea what GraphQL is, I will do a short 3 minutes introduction, and then we head into our actual talk. Just let me go on. Forgot where my clicker is. Just one more second here. Okay. So this is basically, you could say, the hello world of GraphQL. This is a simple GraphQL query that fetches the current user, the currently logged in user of an invented service, of some kind of service. And from the currently logged in user, which is represented by me, we are fetching the name. So just the name from the current user. If you would send in that to our GraphQL server, the GraphQL server would send us back a response that gives us back exactly the data we asked for. And if you look at the request and the response here, it's almost as if the GraphQL server filled up our data graph, our query graph that we sent in, with some data. It is not actually like that. And we will see when we head into more complex examples in this talk that there's more to it than that. But it is a good mental picture to start thinking about GraphQL. You create a request, and the GraphQL server basically fills this request up with data. But it's not only about flat data structures. GraphQL is about more. I can drill into my data. And I can drill into my data without changing my backend. So if I, for instance, wanted to fetch the profile picture for our logged in user, I might just drill into the data and just tell my server that I need the image, maybe the width, the height, and the UL. Just a second, there are more people coming in. So this is not about flat data structures, as I said. I can drill into the data. And if you think about it, it's more the human way, about how we humans think about data. We think about structures, about graphs. And when I drill into the data and send this request basically back to my server, the server again just will fill up my graph. And now we are not talking about flat data structures. We are talking about trees of data. And if you think about what is behind those requests, it is actually allowing us to drill deep into data structures, and by this, solving common problems like the N+1 problem. The N+1 problem actually starts when we have consecutive requests of data, basically what we call data waterfalls or cascading data requests. Like in this example, where we might just fetch the current user, and from the current user, we want the name and maybe the last seen date timestamp, which basically is the point in time when we last logged into our server or were last seen on our platform. And we want to have the same for the friends of this logged in user. This could be useful to build up a friends list in our portal that shows the online status of our friends. If you think about how to solve this with REST, we would probably have two requests. First, fetch the current user, then request the IDs maybe from the friends and fetch the friends for that user. And that is what cascading requests are. Basically requests that wait for each other. You need first the first request in order to get some details from it to issue the next request. But with GraphQL, we just can send that to the server. And the server can solve the data fetching or the data aggregation problems. And by that, we are enabling the server to optimize our requests. It can be to a database, it can be to microservices. And if you think about it, the server can much better access those data because the server is in the cloud maybe, or in our on-premise in our data centers. And the server basically has unlimited bandwidth or much higher bandwidth than we might have on the consuming side, because we might run on a mobile phone with just 3G at the moment. So by putting the data aggregation to the server, we are enabling the server to optimize the data fetching and send us just the compressed response that we actually need. But if we look at that example here, we can see there is a lot of repetition already here. Name, last seen, we use it 2 times. And with GraphQL, there is a solution to that. It's called Fragments. And Fragments is basically a primitive for composition. So it allows us to create fragment hierarchies as we create component hierarchies in our UIs or class hierarchies in our business logic. And that basically closely aligns with how we build UIs, how we build our business logic. We will make heavy use of fragments throughout the talk, and you will see where they are useful. So with GraphQL, we have just one endpoint because the GraphQL server allows us to specify what data we want. And by allowing us that, we just need one endpoint to send in the requests. With REST or other data technologies, we have all those various endpoints because some developer or group of developer predefined ahead of time what request we might need. And this always runs into issues with evolving consumer needs. And with GraphQL, I can fetch everything in one request. Basically, I can define at any given time what data I need or what data my component needs and issue just that. And the server will just give me my response back as I need the data. And with that, I get rid of the over or under fetching problem that I have with other data fetching technologies. And GraphQL is built on a strong type system, meaning we are not only exposing a schema like with Swagger, for instance, we're actually enforcing this schema. Like when we, for instance, in the backend make a mistake, and by doing that, for instance, return null for a non-nullable field. The GraphQL query engine will make sure that this null for a non-nullable field never reaches the client. And this really enables us to just get rid of all the null checks for non-nullable fields, or to check if there is a int for a string field. It really empowers us and makes GraphQL more predictable to use. And with that, I pass over to José, who will talk us through to Blazor. José, you can take over.
Yep, thank you, Michael. So can you see my screen?
Yes.
Blazor. So one of the components is what Michael has explained, GraphQL, and on the other side we have Blazor. Blazor basically works based on a technology that has appeared in the last 2 years called WebAssembly, which is an open standard adopted by all the major browsers. All the modern browser, for example, EA is not one of them, so that's not supported, but it runs basically everywhere, in your mobiles, in your tablets, in your desktop, runs everywhere. And it enables to run kind of a WebAssembly. And on this WebAssembly bytecode that we can compile some programs to run over WebAssembly at near native performance. Here, Steve Sanderson on 2017 had an idea and set up a prototype, and it was based on Mono. It's mono.wasm, which runs over WebAssembly, and then we can run basically everything. And this is what we have on the .NET part. So basically, we have .NET Core, .NET Standard, running in the browser, and that means that we can reuse all the different assemblies that we compile in .NET, including Blazor. Blazor is a .NET DLL that you can run either in your browser or you can run it in the backend. And that means less JavaScript and more .NET. Basically, it's a full stack application on the UI and on the backend. And at near native performance. This is also thanks to WebAssembly, which is taking care of that and is constantly improving. And as Blazor is part of the ASP.NET, it is an open source project. So how does it work? Basically, we create our C# code using Razor syntax. Razor syntax is, for example, a single page application framework that if you are familiar with ASP.NET, you probably have seen, which mixes a bit of HTML code with some add characters, then you can mix code with the HTML in the same page. You can split them if you want, but basically it enables us to run very fast HTML with .NET code that runs quite well. This we compile into a .NET DLL and we deploy it to the browser. And the browser, if they support WebAssembly, which are the most of the browsers, it has something called the WebAssembly VM. This is a sandbox, and by definition, it is secure. That takes the WebAssemblies and then runs or executes and interprets them with the mono WebAssembly runtime, which is compiled. And this will enable to be us to have the power and reuse anything that we can have as code on the server. Either it's a DLL, either share code and execute it internally, or even a NuGet package without any problem. This all works in a shadow DOM in the WebAssembly VM and is synchronized by the JavaScript interoperability layer. Basically, here we have mono.js internally that enables this communication with the real DOM. And this is how we are working with WebAssembly and Blazor. As a current state, Blazor is already in two flavors. One is running in the server that we can run in a IIS or in Azure. And it was shipped with .NET Core 3 in September last year. And we have a quite recent WebAssembly that runs in the browser and executes in the browser, executing natively .NET code, which was shipped like 2 months ago in May 2020. Also, there are some experiments and previews on progressive web applications together with Electron, which are previews with .NET 5. And something called Blazor Native that Steve Sanders has presented recently, which is currently under investigation, that enables us to take out the WebAssembly rendering layer and provide it quite natively in different devices, desktop and tablet and mobile. So let's code a bit. So let's stop talking. That's all for a very fast introduction to Blazor. And what we are going to build today is something that explores real-time capabilities. And what better than implementing sort of a Slack client. Slack is a great example for a real-time application because you can subscribe to different channels on your favorite topics, like, for example, HotChocolate or the .NET User Group, and send messages and be notified of messages. So it's quite reactive. And this is what we're going to build today. Let me jump to code. I guess you can see that now. Let me execute so you can see what we are going to build upon. Yeah, perfect. So I move the mouse so it, we all know that it accelerates the
Loading time. Yeah.
rendering. Yeah, exactly. So this is it. And at the moment, what we are going to do is implement that we get from the backend some data and fill up the people here.
So basically, we are building up the participant list. So all the users that we can communicate with.
Yes. So basically, what are we going to query about? So let me show you Banana Cake Pop. This is what I'm showing now is Banana Cake Pop. And as soon as I get the URL, here, the schema will be populated. This is thanks to introspection and the strongly type. So here I have all the queries, mutations, and descriptions that I can make. Query is the data that I can ask for, like me or people. And what I want at the moment is ask at the people. I added like a authorization layer as I need to be logged in. And let's do a query.
By the way, if you click on the 3 red stripes, these settings icon, then you will get more space.
Yeah, I don't think we need that, but it's quite has intelligence thanks to the schema, and we can check the nodes.
So what José is doing here is basically he's asking the root field people, which exposes to us a collection of people. And we can see the nodes field there, which is basically the relay paging API. That's why we have this nodes field there. And then he's asking for some fields here. In this instance, he's asking for the name and the last scene. Basically the demo query that I showed you in the beginning.
Now I click execute and we can see that we are getting the results we wanted. So we know that the backend is working. This is a GraphQL HotChocolate backend server, which is deployed in Azure. And this is what we are going to work with. So let's stop the code. Let's go back here. And let's take a look at what the program is doing at the moment. This is a client application. This is a Blazor application client. So it will work with WebAssembly, what we just explained. And it is in a concept similar to a JSON that you can run and it executes on your desktop and your browser. Basically, you have the same component or similar component as ASP.NET, ASP.NET Core application, except the startup. And here we are creating a WebAssembly host builder that will render the WebAssembly component. We are adding one component here. WebAssembly is component based. That means we can build pages and we can build components, which is very similar in concept to a Russian doll. So we can build here one container, and inside we can place another container and reuse them. The same concept that the fragments that Michael explained before. And we can do very, very dummy components, as we will see, or we can build components that manage the state and load data, as we will implement in short. And last but not least, we call the build that simply builds all the components in the visual tree and renders the application so we can work. So let's move to the first component, which is app. In this case, it contains just some HTML that contains another component. This is very dummy component. Then we go to main component and we can see, okay, we have another HTML and we have some code that does nothing at the moment. That's okay. This contains people list. And where is people list? It's inside components. And here, let me make it a bit bigger so you can see the names. Here we have people list that it's now some HTML that we can understand.
That's basically what you saw on the left-hand side. That's our list that we want to populate.
Yep, and some code that at the moment does nothing. And if we go to the person placeholder, we will see that also we have nothing in there.
Yeah, it's just HTML, and that was basically the placeholder that José hovered over in the list.
Yep.
And then we have also the person item.
Yeah, but that I will show it later, but that at the moment we are not using. But this we will use in a moment. The first thing we want to do is to enable the client. For this, we have a NuGet package that we have added, which is Strawberry Shake. If we go to manage NuGet packages, installed, we will see very nice shake, Strawberry Shake. This is part of the HotChocolate package, and it is the client of GraphQL implementation of HotChocolate, the same as HotChocolate is the server implementation. This is the client, and we need that. In this case, we have already added it, so we don't need to add it anymore. What we need to do is we need to initialize it. And for this, I need to go back to Banana K-pop and copy the address to add a reference to the backend and initialize it. Okay.
What are you trying to do?
Okay, 1 second, as I cannot see that. Tools, yeah, command line, yes, this developer command prompt. With the change of resolution, I lost a bit that, and we need now to do an initialization. So basically we need to use our favorite command, .NET. We add our second favorite command, and we will do an initialization of the backend address, the only single endpoint that we need. And we will give it a name. This will get the schema, the same that once we put the schema in the backend work. Okay.
So what the initialization command basically does, it downloads the GraphQL HTTP schema. It loads the GraphQL schema and adds it to our project structure. And with that, the Strawberry Shake package basically is able to compile against that schema. GraphQL then doesn't become just an artifact. It really becomes the source of truth, and it hooks up into the compiler.
Yeah, here we downloaded the schema and we have created the client configuration, which has generated a couple of files. One is a chat GraphQL, which is the schema, with all the types and structure, and the other is berry, like strawberry shake, that we cannot see too much, but now it's a bit better, which contains the name that we gave it, the endpoint, and the name that is automatically provided for the client. Now we need to do one more thing, which is add one single element. And this element, we will call it queries with extension GraphQL. And we will copy the query that we just executed, because this is what we want. We want to get the people with the name and last name, because this is what we will show in our application. Once this is there, we build, and some magic will happen thanks to Strawberry Shake. And we have a generated folder that gets this query and builds in code everything that we need to execute it. Like, for example, the person. Exactly what we need, how we need, not more, not less. So here we declare that we want the name and last name of the person, and here is what we get. That's quite efficient. Let's close it there. Let's close this as well. Now we will build everything that we need to execute this. And let's start from inside out. Before we were opening the Russian doll, and now we will close it, starting by the person item. That is what we need. This is what will appear on the left-right side, and we will render one for every single person. So here, we will give it a parameter, and the parameter is the person item. And we are declaring a user, and the user has two properties that we want to show.
And this person item component is really a stateless component.
Mm-hmm.
And Blazor basically works with the concept that you have in other SPA frameworks like React or Angular, where you basically have stateful components and stateless components. And the stateful components basically is where the magic happens. And they basically push down the data, their component tree. And this person item is just the lowest level component. So it's a dumb component. You could reuse it in multiple places.
Then this person item, we are going to reuse it right now in the people list. The people list, it's a bit more smart. It has two parameters instead of one. We have the is loading and the list and collection of people. And here we will replace the person placeholder by something more smart. So we will check if we are loading. This means if the data has finished loading. If we don't have data, we will render like 3 person placeholders. And otherwise, if we have already data, we have people, we will iterate on the persons and render for each person a person item. And as a parameter, we will give it person with a razor syntax.
What you can see there actually is basically that's the property that you introduced in person item, right?
Exactly. Here we have it. So here is the user, which we can pass as a property inside the HTML declaration. We will iterate on the persons and render for each person a person item.
I muted.
Okay.
No worries.
Good. Thanks. So let's move on. So these two are very dummy components. They are stateless, as Michael said. And here we have main. The main is not going to be a dummy component. It's going to be managing state. For once, we are going to put an inject. This will resolve this interface, iChat client, which is generated by Strawberry Cheesecake, which we call chat client. For other, we render the people list And we pass two parameters. One is the list of people, and the other if it's loading or not. And then we will add the parameters. Well, sorry, the variables that we will load in a moment. One is if loading. By default is true because we have not loading. We are still loading. We have not finished loading the data. And on another, we have the person connection, which holds the list of people. Next but not least, we will implement one of the variables of a component that renders when executes when we are rendering on the render process, which is uninitializing. This class, sorry, this method executes when we are starting one component right away. And if we override it, we can add code that we want to happen when before the object is rendering. Here, what we are getting is calling the chat client and telling it to get people in a synchronous way. And once it is done, we will ensure that this result has no errors and put the list of people inside the people variable that we declare here. So it's already populated. And next we will tell, okay, it's not anymore loading. So this way we have managed the state. The next thing we have to do is tell, okay, Blazor, render again. And this is done by the state has changed. This issues a notification on the render tree and issues all components to re-render in cascading. So this component and all the innermost components. This is one of the things we have to do. The next thing is, as ASP.NET, we have to configure the dependency injection so that our application can resolve the iChat client. If we run now, this will not work. And this we are doing on the program CS. If somebody has experience with Blazor before, but way before, we had the startup and we had to do that there, the configuration, and now everything is done in the program CS. This is
there's actually also a new template coming up with the startup CS. So they try to match more the way you would configure in.
So they are putting it again.
Yeah, I don't know.
They put it in, they take it out, they put it again. Oh well.
Yeah.
But well, we will see. I think it's funny. So the first thing is we add the chat client, and this is an auto-configure method that is also added on the generated, which is quite a good practice. And on the second part, we add the chat client, sorry, the HTTP client. We need to add the reference here and the usings and the URI.
And this is actually crucial. This is not something from Strawberry Shake.
No.
So GraphQL in essence is transport agnostic, meaning that the chat client that is generated is transport agnostic. And what José just did there is he added the HTTP client factory from Microsoft. It's the HTTP client factory we are using in the backend, right? It's the same thing that we are using in ASP.NET Core or in WPF applications. And also the dependency injection is just these standard dependency injections that we use in the backend. And that's really powerful. It's not like Silverlight where we just had this castrated API. We can basically use anything that we have in .NET Core and just reuse it in Blazor.
Don't use that words when you talk about Silverlight, Michael. You're offending me. Come on. Good. So now what I did, meanwhile, Michael was doing is I copied the authorization token, which I recently authenticated because the one that was in place was clearly expired. And now we have everything. So I have configured the base address for the backend, configured the HTTP client for the chat client, as Michael explained, thanks. And we have everything in place for having it run properly. So now let's see if the gods of software are with us and it will run the first time. So let's try it. Yeah, well, should work. Come on.
Yeah.
When I added the client, I had to repeat it somehow. it was not working finally. Oh, perfect, nice. So now we have it. We have here the list of the people with a nicer logo. We have Michael, Jose, Olivia, and you, the audience. Cool. It works. So that's cool. Yes.
It's alive.
Yeah. So now I will hand the session over to Michael. So he will move it forward and show how we can use mutations to change the data and subscribe to events to get notified of messages.
Yeah, just let me skip all the slides that you did.
Okay.
It's more difficult to do that with José not even being in the same room as I am. But okay, we try to manage. So we built basically up the people list. That is the person that we can chat with. But that's actually just a small thing. You could do that with anything. Now we are going into the more complicated stuff. And what we basically will build now is the message area. And if you remember how maybe iMessage works or how Slack works, we have those message bubbles. And depending on who's sending something in, we see it on the left-hand side or the right-hand side. And at the bottom, we need something in the footer area where we can type up some messages, just to write our messages. And maybe we have also some statistics in the header area, like how many messages are there, who am I talking to, and metadata like that. And as José already said, these are different interactions with data. Like in GraphQL, we actually have three types of, three operation types, or three different kinds how we interact with data. We have queries, and basically what José did was writing up a query, fetching data. That is a side effect reading of data. And then we have something like that's called a mutation. And when we write up a message, and that's what we are going to do next, is basically we are mutating state on the server. We are changing the state of the server, changing data. And the third thing is a subscription. And basically, the subscription allows us to receive data as they change on the server side. So basically, the server is pushing down data to the client actively. There's no pulling. Okay. As we have done, and now I lost my clicker. Let's move on to the next demo. And I am also switching gears here because I'm on a Mac. Let's use Visual Studio Code, which also should be faster, I hope. Let me just .NET Watch run. Basically, the .NET CLI will compile the project, and every time we change now something on our project, it will automatically recompile it. And let's see where we left off. Just let's see if everything runs. I made the left-hand side a bit more nicer than José left it off. A bit more formatted. Okay, I unmute you, José, by the way.
Yeah, okay, now I can reply. Come on.
Yeah. I didn't allow attendees just to unmute so we don't have some disturbances, but I saw that you wanted to say something. So, okay, so this is basically where José left off. We have our list here of the participants. And if we click on one of these participants, we would like to see the messages or the interactions that we have with that particular participant. And also, when we then have the message stream with that user, we want to, down here in the area, we want to have some text box to type up some messages. And every time something changes in our API, we want to automatically messages appear in our message area. So let's go back to our API, our Blazor client here. So this is how we have structured our query for now. There are no fragments in there. It's just a simple fetch. and just some data that we fetched. The next thing we actually have to restructure before we even can start with our components is we need to think about what data we need at what given moment. So let's just grab that query and maybe reason a bit more about our data. Put that in here. Maybe just execute it. Look at the data. Okay, so this is a query. The next thing is that we want to do is writing some kind of a message. So we talked about mutations. Mutations are our way in GraphQL to mutate data. So in order to write messages to our server, we might create a mutation that is called write message. And if we look at our mutations that are available, we can see we can create a user, we can invite friends, we can log in, and there is something called send message. Or maybe we call our mutation then send message. We can call it however we want. And this message has an input. And that is actually an object. So an input object, it's called in GraphQL. And basically has two fields. It has a recipient email, which is the person to which we want to send our message. Okay, let's just put in an empty string for now. And then we have a text. And the text is actually the message that we want to send. We also put in an empty string and fill it in later. Okay, the next thing is we get something back. In GraphQL, a field always gives something back. We never have something like a void, just sending something in and don't getting anything back. And in GraphQL, actually, a mutation is only the top part. So this is the mutation. And everything beneath the mutation, or everything that the mutation returns, is a changed state of the server. So GraphQL allows us to change the state on the server and then query the changed state of the server. And by allowing us to do that, we can then fetch in maybe the ID that from this new message, or maybe we can see here the recipient is changed because the recipient has a message collection, and this message collection now includes this new message. So we can query all the affected objects. Okay, in our case, we are grabbing the message that we just created because we want to have that, and just insert this created message with all its IDs into maybe our message collection. Okay, and as we explore here, our message has an ID. That's good to know. It has a direction, also good. And then we can see here we have something called a recipient. And a recipient is actually a person. And what we query above here is also we are querying people, which actually are persons. So just let's grab the name, for instance, for now. We actually need more, but let's just start with the name here. Then we have the sender. We also grab the name just for now. And then we can see the send date might be a useful thing, so for ordering or maybe stuff like that. And then we have, last but not least, the actual message text that we did. So if we revisit that, we might want to have the name, email, and is online state for our component. We will have a look at the components later, but I already know that we need that. This is kind of useful. So we add that here and here. And then when I started this talk, I said we have this primitive or composition, this fragment. So let's start building up fragments, because these are the same. And actually, I might want to create a fragment. And I might want to create this fragment a participant. So, and the fragment are applied on types. So I'm applying it on a person here. Person. And then I can just grab these fields that I have up here and put them in a fragment. Okay, he squiggles me the fragment because GraphQL has a rule, fragments have to be used. So in order to use a fragment, I'm starting with 3 dots here and then pasting in the fragment. And I'm doing the same here. And just let me unknown fragment. That is strange. Person. There's something wrong. Let me just figure that out. Ah, there. Okay. There was one squiggle at the end, one brace at the end that didn't belong there. Let's just get rid of that. Get rid of everything here. And see, syntax error, EOF not found. Ah, okay. That belongs actually here. Let's do that. Ah, so reformat it and be done with it. So what we have now here is we are referring to this participant here. And if we look closer, actually, let me just remove this bar so we have more space. We can see we are using that here also. So let's just say this is also a participant. And actually, the rest of this is our person, the person that we interact with. So we could introduce another fragment here that is called person. Bear with me a little bit longer. It will make all sense in a minute. So we paste in this, this fields and the reference to the participant, and we can now see that we can basically build fragment hierarchies. That means fragment in fragments. And I can basically put up the same here. So now I'm using here a person and here the participants. And I might also want to establish another term for my domain API or my domain model. I might want to establish something called a message. And the message is basically on the message. So I'm actually defining with that. On my client, the message looks like the following. And I grab this here, putting it in. And then I actually refer here to the message. And now my operations are these guys here, or this guy here, is much cleaner to read first. I can see, okay, I'm executing this query or I'm executing this mutation, and actually what I'm getting back or what I'm consuming is this data structure or my fragment here, what I've defined here. Okay, so I defined my mutation send message. The next thing I need is also to load the messages initially is another query maybe. In this query, we call maybe get messages. Let's do that. And how do we get messages? We want to get the messages for a specific person. And the server, through our token, already knows who we are. So I can just grab the specific person by its email address and then fetch this person. And I also have a fragment for persons. So I can say get my person is again the person fragment. Okay, so we actually have the API that we need for our components to get started. But we still have those empty strings here. And GraphQL has a concept about variables. And the variables basically for us is our parameters into the method. So if I'm now defining here an email, and this email is a string, and the string is never null, then I can use that in my query structure here. And by doing this, I now have basically a method in the C# naming context. This is actually called an operation, as I said, with a parameter email and which is of the type string. So basically, I can pass this in and get the result to that back. And we grab that and also add that to our send message operation down here. But we also need here a text And this text is also never null because a null message is kind of weird for a user to write. So we just say it's never null. Okay, so if we feed that in, and then we have actually the operations that we need. So let's grab that and feed that back to our queries GraphQL. We paste that in. We just recompile, or actually my .NET Watch Run already recompiles and dies, which is always good. But it doesn't matter.
See.
It's coming back. It's coming back. And it generated. Yeah, it's because I built and had, basically I had two competing builds now. Okay, so when we look now at our generated code here, we can see that we have a participant. And participant was this fragment that I specified. Okay, that's interesting. And I can see here's a interface, person. And person implements participant. So the fragments give me power to actually define how my C# API will look like and is named like. By using a fragment in a fragment, I basically create an implementation hierarchy. And that's what I said in the beginning. As we have fragment hierarchies, we actually have class hierarchies and component hierarchies. Okay, so this really empowers us to build something, but there's still something wrong. Let me stop that. Compile it and hope it recovers. Okay. Let's get into the components. So as I showed you, we are now in power of creating our custom data structure just for our client, just as we need it. I already prepared some components here. I just uncommented them. So let's comment them in and I'll walk you a bit through the structure here. Because building all those components live would take, I think, more than an hour. That's why I just prepared them and we feed in what we need. Okay, so the main Razor component is as we left it off. We basically have our people list here, and we have our initialize function. And I already added some private functions on click and on click send. And what I also added is an event on my people list. Whenever I click on something, I basically get an event now back. It's a .NET event, like we have in WPF. And that triggers this method. And that's it for the main component. And we can have a look at the quick look, because that's more complicated than you think. We can see there is a chat message component, which basically has, depending on the direction, why I selected the direction. Depending on the direction, we are showing the bubble on the left or the right-hand side. And the good thing always with Razor is that I can write this C# code here and then basically put HTML in and have like branches for my HTML. Again, this is a dumb component. It just gets data in, and it actually has no events because it's just the message bubble. Then we have the footer, which again is a dumb component. It's reusable in many places. We have the text area, which is up here, the text area where we can write things in. And then we have an event. So this is an event. It's also a property, a parameter where we can basically pass in a method that is then triggered. And we have the on-click send method that actually raises this event when we click on it. So very, very C#y. So this is what we .NET developers really understand. And then we have a message list. And that is the component that really brings all the components together, has the logic when something is loading. We are showing a loading indicator. And in other cases, we do a for each of the messages and add more chat message components in here. And also we have here the parameters and pass in the data down the component tree. Okay, so let's bring that together. First, let's really fetch data. So when we click on the person that we want to select, we need to load some code. So I prepared this message snippet so you don't see me typing stupid stuff here. So what we are doing is we are using our chat client that we introduced with our first example. And now we are fetching the message through the get messages operation. And again, this get message operation name comes from the operation that I defined in my GraphQL. So by writing here, get messages, it becomes a method on my client that is called get messages here. So it becomes a standard.NET method. And the variable actually becomes just a parameter. And I can pass in, for instance, the person on which I clicked. Again, José explained that already. We ensure that there are no errors. And then put the person on something that we don't have yet. Another field that we have to introduce. I will do it in a minute. And then we basically create a message list, which is an immutable list, and add the message that we received. So the reselected data, we add it to our messages list. And we might log something to our console, like in any good C# program, we just can log to a console for some debugging, not the recommended way, but we could do it. And it actually just writes into the Chrome Develop Tools console, which is kind of cool. Okay, so let's put in some properties here. So I can see I need a recipient property for my person. So let's put in the private person. That is a recipient. And if you can hear my children crying in the background, that is how working from home works. Okay, we put in the message list here. It's an immutable list of iMessage, which we call messages. And let's let it be an empty list at the beginning because we don't have anything at the beginning. And then everything works. Okay, awesome. This should now compile. But I can see we have this person by email. And actually, this field, we didn't reselect the messages in the way that my prepared code expected it. And that's because the get messages here actually reselect the person, which is not what we actually want. We actually want to get the messages that we have with that person and then say, we don't want that person because that would be stupid. We have this person already. We just reselect the message here. Okay. This is not what I want. Why is he complaining? Ah, yes. There is the notes field or paging field missing. Okay. Let's put that back into our queries GraphQL. Recompile it. Working. Then go back to our component here. And actually, we should now, is it still compiling? We should get now back our person by email. Messages, yes. Okay. So now it doesn't have a compile error anymore. We have the messages, we're selecting the message nodes, which are then messages, and updating our message list. But this is not what we just want. We don't just want to fill up a list in our memory. We also want to display it. So we need to add the message list, our component, to our main component to make it visible. So let's add the message list. Prepare this snippet and recompile it. And I should start .NET Watch again because The problem is at the moment, why I'm struggling a bit, is that the Zoom window always is in the place where I want to type. I have to. Okay. So while our client is getting up, let's head over to Chrome. And I have to, again, move the Zoom window away. Refresh that. We get our people list basically here. We can, for instance, click on José and nothing happens, which is very sad. Let's check our code. List, if this is intended, found markup element with unexpected message list. Let's see message list. Okay, now let's do live debugging. Immutable iMessage messages. That is right. This should work, or if this is intended to be. Ah, okay. I know what it is. Add using. This is actually not my usual demo that I use. So let's put in the namespace here, which was the, just wait a second, imports components, and then put in the, what is it? Chat. Okay, there was a namespace missing. That's why it didn't come together as I expected it.
By the way, these usings that we are putting them below are global to all the application. So if you put a using in there, you don't need to reference them anywhere in the
Yes.
Blazor application.
Yes, because the components basically are built into each other, and that's also, you can put all your usings in one specific component and they are built together. Okay, so I can now click on José and I see all the messages that I write with José. You can see the debug sessions for this session. That's cool. Okay, let's write a message. Hello, José. Send it. Actually, nothing happens. That is to be expected because we didn't implement it. Okay, but we can select the messages. That is good. Let's build in the mutation. So when we click on send, what I just did and what did nothing, we actually want to send in the message to our GraphQL server. So let me put in the code here and I explain it. So we also defined a method that called, or an operation that is called send messages or send message. And we basically grab the recipient that we added here to our recipient property, and we grab from it the email. And then we pass along the message that is basically passed in from the event and send it to the server. And the server will, we ensure that the result is basically has no errors. Then we update our message list. And what I did forget here and also up there is to trigger the state has changed. So the component tree or my child components are updated. Okay, let's do that. It's recompiling. Okay, should be working. And go back to José, move the Zoom window away. José is good. He answered my question that I couldn't send him. Hi, José, send in. And I can see I sent in the message. And it's not only on my client. If I refetch it, it's basically still there. How are you? Oh, it's not there. I think the messages are not correctly ordered.
We need to
yes,
put that in there.
Yeah. So with HotChocolate, you have basically a filtering API, so you can actually pass in orders or wheres. It's not a GraphQL standard, but with HotChocolate, you can do that, and it's translated in native database queries if your system supports it.
And
So,
one thing to highlight is that you can do at any level of the N+1. So you can do at the person level, you can do at the message, and if you nest any other data, you can do at that level as well.
But what is good to see here is, as I'm debugging my client and seeing issues in my requests, I can fix them. I don't have to run to my backend developer to say, okay, this status wrongly sorted. I can do that. Let's refetch that.
Oops.
Not yet up. No, it's not yet up. It's compiling still. No. Started.
Don't forget to move the mouse.
Don't know what it's happening today. Usually it works. Don't it run? Very good.
Well, today is live, so well, you know, Murphy lives.
Just let's refresh that. Okay, I can refetch it. I can go to José, and I see it's now correctly ordered. Here's my hi José, which was wrongly ordered. Okay, so that's still not awesome. We just have a fetch. We have a mutation now where we change data, but the real magic really happens when we get real-time applications. And let me just admit some user here. Okay, so let's grab our GraphQL query and further make it great again. Okay. So we have query, we have mutation, and now we want to have real-time data. And what's really awesome with GraphQL is that it's basically nothing different from a mutation or a query. I just have to type subscription. And that means I'm subscribing to something from the server, and the server basically sends data down to me. And I could call that on message received, and then ask for the subscriptions that are available on my server, or the events that are available on my server. I, for instance, have here an on-message received event. That's what I want. So every time I receive a message, I want this message. And I actually can just, again, use my message shape because I know how my messages look like, how I want them to be structured. And actually, there's one more thing in GraphQL, because I don't have to accept the names of the fields that GraphQL gives me. So I can set an alias here and say, okay, message is actually what I want to call this field. Okay, let's just grab that. You saw it's just 5 lines of code. And I can grab that, insert it into my queries here. Let's cancel that, recompile it. Should have done that. And then we head to our main component, our smart component that holds all the state, and insert on message received. I usually have a snippet. I can code it also if I don't find it. Okay. Yeah, begin receive. So basically, I'm now want to receive asynchronously data. And I have to spin up some kind of a background thread for it. So I can just say begin receive messages. And then I can create a new task run. And that's also cool because I just can do task run in the browser. And then I have a background task. And then I, again, ask my chat client here to, I think I called it on message received in this example, to do an on message received async. And what it actually does is it creates a WebSocket connection, or it creates a subscription actually. And then I'll get back something called a response stream. And the response stream is like a stream of query results. So every time the server produces a new query result for my event, I get this result pushed down to my client. And with those async streams, I basically can say await for each. That's new with the newest .NET version, basically, or the newest C# version. And then I can basically for each over the stream until the server says this stream is completed, or I could also complete it on the client side and say, okay, server, I have enough. Okay, so then every time I receive a message, I basically put it to our list that we have up there, and trigger state has changed. So when we initialize our component, first thing that I will do is just start this method, and it will start receiving those messages. Okay, basically that was it. That was real time. That's all we had to do. Let's .NET run. Oh no, it will not work. And because if we go back to our program CS, we can see we have an HTTP client there. But now we are talking about active data pushing, so that the server can push data to us at any given time. And that doesn't work really over HTTP. So we need something else. And we need WebSockets. And if you think about how to set up WebSockets and do all this stuff, it's really difficult, like pooling connections and then doing multiple subscriptions over them to not have too many connections to the server. That's difficult. But actually what our Strawberry Shake client also did is generate something like the HTTP client factory. And that is basically a WebSocket factory. So we can say add WebSocket client here. And we actually can just copy and paste this configuration. It doesn't fully align, so we have to edit it. But okay, for base address, we can say we have a URI. And actually HTTPS is WSS because it's a secure WebSocket connection. This stays the same, but let me move the Zoom window away again. But we have, in this instance, we are passing a token over the URL. I wouldn't do that in real life. I would actually pass the token over the messages, but then I would have to introduce more concepts here that we don't have time for. So we pass in the same token that we use here. We get rid of that. But apart from that, it's very similar to use. This WebSocket factory compared to the HTTP client factory. With that, our client will work now. I don't run that. Let's go here, refresh that. Okay. Let's write to José. Hello, José. I'm sending lots of hello, Josés. Let's see if you can write back.
I'm recompiling at the moment my client.
Oh, God.
Yeah. No. But it worked the first time, so.
But the audience can also, if you guys want to chime in and chat, send something into my debug session, help me load test my thing here. Go to chat audience azurewebsites.net and you can just send in messages. I'm waiting here.
You can see I'm responding to you already.
Maybe if everything went right. Oh, I get messages. And there's the audience. That's basically when you're responding over the link. Yeah, that's really awesome. So we can see that there are messages from José and also from you guys. And it was quite simple. We just specified some GraphQL with the GraphQL query language, and all the complexity was abstracted by Strawberry Shake. Bacon is good. I love bacon. My kids love bacon, but yeah. Spam. Okay, let's move on. You survived, and we had a lot of mistakes, but doesn't matter. We fixed them. We debugged live with you guys. That's what is great about user group sessions. You can do it a bit longer and debug live with the audience. So what is the takeaway here? With Blazor and GraphQL, we can iterate faster. Why is that? Because we can just use C#. Like, we don't have to learn this pesky JavaScript anymore. We can use it. Yeah, JavaScript is also good, but I cannot write it, so I like to use Blazor. And it makes me able to create awesome UIs. I wasn't able to do that before. If I did React, my colleagues would punch me for that. So now I'm a front-end developer as well as a back-end developer. That's cool. And also, we don't have the friction between the back-end developer and the front-end developer, because with GraphQL, we can specify what data we need and want at one given point in time. That makes us super efficient. José, do you have anything to add to that?
One thing very powerful that happened in between the lines is that we were adding suddenly some features that usually would require to do some modifications in the backend API if we were using REST. Like, for example, okay, give me this data in this order that I want, like the messages, right? Or we could need, okay, now I want, instead of getting only the name of the people, of the person, and the is online, we can also get, okay, give me if that person is typing or not, or suddenly subscribe if, and we don't need to create another endpoint for that. If we define properly what we're exposing, we can get the data right away from the client. And we don't need to make custom REST endpoints and go to the REST or the API developer and ask them to do that. And you have been there, it can take 1 day, 1 hour, maybe more than 1 day, depends on the priority. So in this case, we are not depending on a backend developer. This is a true meaning of iterate faster. We have all the power in the client. Either it's Blazor, either it's ASP.NET. If we run it in the client or any client, this is going to work in any client to consume in a proper way GraphQL. I think it's pretty powerful.
Yeah, with GraphQL, it's more like that. The backend developer defines the overall domain model. And basically he says, here's my domain model. Here's all the world that you can explore and from which you can grab data or which you can combine and stuff like that. And then the front-end developer can pick and choose from that.
One thing to say is you're exposing the domain model that you want to expose. So you have to define that clearly. You should not expose like a domain model automatically generated through the database. So you restrict that to the queries you want to do and also to the data or the schema which is offered. And you usually secure that in a proper way, as some data may be sensible.
Yes, and the ideal way, or how Facebook is doing, is basically they have a very thin GraphQL layer on top of their business logic. That means that's why they advertise GraphQL also, that it's a query language for your API. It's not, you can do stuff like we do in HotChocolate, where we allow you to basically infer also the database, query on the database, but you can also have a very strict model that reflects your internal API. And if you reflect on that, the GraphQL gives you a better way to really share your API with users. It's not like with REST, where you have to basically somehow find a way to expose your API in some way, or which not always works, because you have those type limitations. With GraphQL, you can let users really use your domain API from the backend. And this really gives you, as a backend developer, the power to mold how people use your APIs. It's really a chance. Sometimes backend developers are taken a bit off because they think, oh, then I'm giving basically all my front-end developers the way to arbitrarily query all my data. That will not go down well. No, it actually gives you a chance to really enforce that types are that the type structure is valid, that people can use the API in the way you intend to. So it's a very powerful way to explore data. Okay, let's move on, because we have some just some more slides. It's not a lot. We are still working on Strawberry Shake. It's a preview. We're targeting end of July or so. It might come out later, because we are also adding new stuff. Like at the moment, we are molding the idea to add in really, with the first version already, client store like in Relay or in Apollo, so that you don't have to worry about client-side caching and stuff like that. So yeah, really putting in more stuff into Strawberry Shake at the moment. And also, you saw the pity of José's Visual Studio. It didn't have proper highlighting of GraphQL, and he had to use console tools. I like personally in Visual Studio Code, but I know a lot of proper Visual Studio developers like to click at some places. So we are adding, or we are working on an integration into Visual Studio, where you just can right-click on your project and say add GraphQL client, and then it all sets everything up. And also
the compilation should happen in the same time as well.
It does. It's because you're doing something wrong.
Okay, it's my fault then.
No, I think the issue is you have the project open, and then you're initializing it, and it needs to be initialized when you open the project, and then you have design time compilation already.
Okay.
It's just a timing issue, and this will also go away when you basically right-click on the project and add the GraphQL client. But we are not done there. I said GraphQL is transport agnostic, and we are also working on a gRPC integration, so that you basically can put GraphQL over gRPC. That is a server and a client feature. So we are working on that. If you have further questions, you can either head to our repository on GitHub. We have a Slack channel, so you can sign up with Slack, and then we can talk there. But we can also start a discussion. So I gave everyone the right to unmute themselves. So we will stop streaming in a minute, and then you can just unmute yourself and ask questions or
Oh, wait. Let's not do that, because we have some questions, and I believe it would be really good to respond them while we are still streaming, so they are captured.
I did forget that. José, do you want to share them?
Yes,
sharing.
Sure. Let me add that to my screen, and I will share. So the first one would be, I'm starting to explore GraphQL. Is any data storage system, SQL Server, Mongo, suitable to GraphQL, or there is some less suite?
Actually, it really doesn't matter. So if you're starting with HotChocolate, we will support any of them. We personally at Swiss Life, because I'm working as an external consultant at Swiss Life at the moment, and there we are using Mongo database. But you could also use SQL Server. I know some users. I think we have some friends at Autoguru in Australia. They're using SQL Server. You can basically use anything. And we understand at the moment with version 10, we understand everything that is exposable to iQueryable. With version 11, which is upcoming, and we are still working on that, we can understand anything you can, and we understand also raw SQL.
What about the optimizations, Michael? There are some databases that have better optimization underlying.
You mean regarding the selection of data? It's
Exactly.
it doesn't really matter. Just let me pull up something. There's a good blog post I wrote. It's not good because I wrote it. I wrote a blog post on that topic. And you basically can see that we are translating the incoming GraphQL request into one SQL request in that instance. And we basically optimize for your backend system. If you have a database behind that, then we translate it into your database. But there are also like other ways to do your graph. Like Facebook, for instance, wouldn't let you rawly select on your data. So you would rather have really exposed, they really put the GraphQL layer on top of their business logic. And they have something called a data loader, which basically would aggregate all the fetches to your database and then fetch them in one batch. So there are multiple ways to work with databases. And I wouldn't say that one database is better suited than the other. I mean,
Okay.
There are always down and upsides.
So the next one I will mark as answer is I will respond it. Would you suggest using GraphQL in a Blazor server app? If so, how? That's very easy. It's the same that we did for the client, should work for the backend. The same exactly. It's a .NET Core application running .NET Standard with Strawberry Shake. What we are building here also will work on the backend.
I think what he means might be because it's running in the server, should we still hop onto a GraphQL server to select the data?
Yes. We are also moving that as close as the database as possible, and that's always an improvement.
Yeah,
So
but the question is, do you need a GraphQL layer when your Blazor is running in the server? Or could you just select on the database from the Blazor server application? I would say still you should use some abstraction there, because selecting from the data on top of the or selecting data from the database or the raw data stores in your UI layer feels kind of wrong. I would still have an abstraction for my service layer there, but it depends.
Well, it depends on the architecture, of course, but if you want to decouple the UI from the consuming of the data, then maybe yes.
Yeah. And the cool thing is we are working actively on, we need that in Swiss Life at the moment, is that we use the raw query executor, the GraphQL query executor, to feed Strawberry Shake. As I said, it's transport agnostic, and you can also get rid of the transport and just say, Strawberry Shake, here's my execution engine. We are running in the same domain, in the same process, and just use this execution engine that is in the dependency injection. And then you basically do GraphQL without transport. That could be a solution for you.
Nice. So the other is Blazor very much reminds me to WPF/E, aka Silverlight, which was introduced 2007. So how do we know it is not abandoned like Silverlight? I will say that at the moment, this is part of the ASP.NET code base, which is open source. And on another part, we cannot get rid of WebAssembly. It is adopted widely by the industry. So we have the Uno platform working on that. We have Unity 3D, the game engine, which is since 1 year already deploying applications in running over WebAssembly using a similar approach that Microsoft is doing with Blazor.
Yeah, that's true. So one point I agree is it's built on WebAssembly. It's a standard. But that doesn't ensure that Microsoft is supporting Blazor forever. But I mean, it's with everything. The thing why I think Microsoft it's a safe bet at the moment is because they are putting so much effort into Blazor, making it possible that you can reuse your knowledge, not only that you can reuse your development knowledge from the server and really move it into the desktop. And there are a lot more experiments coming around Blazor. So they're putting a lot of their eggs into the Blazor basket. And that's why I think it won't just vanish.
I think so as well. Next question is, how would you suggest monitoring traffic on the wire with GraphQL, like using Fiddler on REST?
How would you suggest traffic on the wire?
Yep.
I would just use Fiddler or stuff like that we always have. It depends on the aim for this question. Do you mean it like how can we optimize the data that is transferred between my GraphQL server or my client? Like monitoring, I would use what you still have. But there are ways to optimize the requests between server and client, like you could use, for instance, persistent queries. And for monitoring, there are integrations with event tracing for Windows, for instance, or things like that that you could use to fill your own monitoring solution, at least if you're using HotChocolate.
Cool. So one more, and would you suggest using classes, models, or interfaces on the GraphQL server?
Classes, models, or interfaces?
I guess it's for exposing the data. So one thing I would say, when you are implementing GraphQL, one of the easiest ways is to do that against a hierarchy of classes that represent the model you want to expose. Then basically you implement like EF, and you expose the EF. And if you implement with this queryable, then it's you can expose that right away with GraphQL on the server. Please, Michael, correct me, but I think that's basically it.
I would say it really depends on where you're coming from. Yeah, there are so many approaches that HotChocolate offers.
Yes.
Like, do you want to go code first, which is code first with schema types, or do you want to go pure code first, where you just expose your model and then we cleanly infer from that model your schema? Or do you go the route of SDL first, where you write everything in GraphQL and the GraphQL syntax and then bind it to a type model? It depends. Subscribing to.
Okay, so when subscribing to a subscription, what is the best way to detect that all the subscriptions are disconnected and then perform some custom actions?
I'm writing a blog post at the moment about the about version 11, because at the moment it's also possible you basically can like a subscription internally in HotChocolate is represented through an async enumerable. And the enumerator that is created by this enumerable is disposable. And this is actually disposed when we disconnect. But it is not explicit enough. So we are changing that in 11, that we have something called a source stream. And then you have more control about connecting and disconnecting. And we're also introducing some new diagnostic APIs that allow you to trace that. And we also give you some lifetime events. So there's much more coming. I'm at the moment writing that blog post. It should be out end of the week, when we hopefully start previewing the new execution engine of HotChocolate.
Okay, good. So I give it for granted. Would you say Blazor is already production ready? Would you recommend it? Any known issues? Well, I would say that it's not me who says that. It's Microsoft. It's production ready since 2 months. And if you want to look at the issues, you can go to github.com/.net/asp.NET Core.
I would even go further, José, because
yes.
actually Blazor is production ready for over a year. Blazor for server.
Yeah.
So what is the difference between Blazor for WebAssembly and Blazor for server? And if you're looking from the outside, you're saying, why do they have 1, 2, 3, 4, 5 different versions of Blazor? But Blazor is actually a very good model. So it abstracts how you update or how you render components. And Blazor for server and Blazor for WebAssembly basically abstracted how they update the DOM. And Blazor for server is the same model basically. And they have also the same JavaScript components that update your DOM in the server. Just they have with Blazor for server a signal channel over which they basically batch those changes to the DOM. Like when José showed this diagram about how this how the structure basically works, we had this router, this JavaScript router that patched changes onto our DOM, and we had this virtual DOM or this shadow DOM. And with Blazor for server, we have the same thing. It's just in the backend, and we have the shadow DOM in this instance in the backend. So the new stuff is really the runtime mono, but we have that for longer. There's things José is always mentioning the Uno platform. They're using the mono platform for quite a while. And the other new thing is that the parts that they now use to update. So really the whole Blazor stack is validated. It works. There is just some new stuff around it to update it from the WebAssembly VM out, and there is tooling stuff. So I would say it's pretty stable.
Yep. So a fake data streams aren't supported in GraphQL. How would you recommend implementing it? Still using GraphQL and base 64 binary type, or adding a REST endpoint?
A fake? What is a fake? Simon, are you on the call? You can also unmute and explain what you mean. Is he still on here?
Yeah, I think it's, as far as I know, a fake.
As far as I know, data streams aren't supported in GraphQL. Okay. You mean real streams? Depends. It kind of. So what I showed is a subscription. And subscription is not a data stream in the common sense. But Facebook is already using for years data streams in GraphQL. And it's actually, at the moment, it's ratified on the spec repository. So if you go to the spec repository of GraphQL, there is an issue called defer and stream. So HotChocolate will release with version 11 stream and defer, those both directives, and then you can basically have stream APIs, have data streams, and also have deferred data. And but it's still being specified, so there will be changes on that. So I would say next year it will be fully spec'd.
Will be the client source code available to download? I would say yes.
Which client do you mean?
What the code that we just shown.
Yes.
In fact, I believe it is already, right?
Yeah, it's I had a similar talk at the NEC Oslo, and the code is already in my on my GitHub repository.
We will publish it in the meetup later on.
Is José using a Surface device? No.
Nope. Good. Is it possible to use an in-memory cache with GraphQL? Do you have any tricks for queries which should perform really fast?
Yes, there is an open issue. We started it 3 days ago to bring cache control, the cache control feature to HotChocolate. We are working on that. So, but you could even do it. It depends. You could do caching on your own. It would be basically a field middleware where you introduce some caching there, and grab the result and define how this should be cached. So it basically comes down to a middleware. But we are making that. We are building out middlewares for caching at the moment, and they will be plug and play.
Mm-hmm. Cool. And then last but not least, what about test? do we need to depend only on front-end unit tests? I would say no. You can define tests on the front end and on the backend on the server.
Yes,
without
I
problem.
would. There is also, I wrote a blog post about writing integration tests against your GraphQL layer. And we're using Snapshooter for that to do snapshot tests. And yeah, you can have a look at that. Our blog post.
Cool. So I think we are done, unless somebody wants to add any other question. We will close now.
Yeah, we will stop the streaming, and you can stay on, and we can have a chat if you guys want to.
So we are stop streaming in 1, 2, 3 now.
Okay, so everybody should